Hello, welcome and thank you for joining today's session on the best practices for securing APIs and application. We look forward to talking about Google security solution with you today. My name is Sachin Kalra and I am a customer engineer specializing on Google's Apigee API management platform. And today I am joined with my wonderful colleague Sai, and I will quickly let him introduce himself.
Thanks, Sachin. Hello, everyone. My name is Sai Sharan Vaidyanathan. I'm a solution architect specializing on the Google's Apigee API management platform. Nice to meet you all and hope you enjoy the content we have for you.
Thank you, Sai. As I mentioned, we have an exciting agenda to share with you today. The first topic that we want to discuss today is the need for security, as this will help set the context on the various aspects of security to be taken into consideration, like API security, web application security, etc. We will like to share the best practices that most of the organizations have been taking to protect confidentiality, integrity, and availability of information. And lastly, towards the end, we will love to give you a quick walkthrough of the security solution by the means of a quick demo, and hope you all will like that. What is information security and why it is important? I want to get started with that. So it is the protection of information and the information systems from any kind of unauthorized access, disclosure, disruption, or destruction of information in order to provide confidentiality, integrity, and availability. Today, as we see, there is a much higher need for protecting organizations' information and the information assets than any other time, as there are so many existing and emerging threats that we see today. And if I were to name a few of those, the top of the mind that comes to me is like the malware attack, the phishing attack. You have anti-DDoS, you have reflective DDoS, account hijacking, so on and so forth. Before before we talk about the security solution, let me quickly share some of the security statistics that we have learned over the years to put the things into perspective. CSO Online finds that 61% of the organizations say that their business strategy relies on API integration, and there is a higher need to secure these APIs. There is another recent study that showed 55% of the organizations experience a DDoS attack at least every month, which is really scary. And the number of reported cyber attacks on the US companies rose by 69% in 2020 from the previous year, from the previous year, my bad, which is a big uptake. That is where API and web security comes into the play. We all understand API usage in application development has become the trend of the year. The adoption of the microservices, the adoption of the serverless architecture has only accelerated this trend of API usage. I want to take a quick minute and talk about what are these APIs. So APIs are the means which allows developer to create an open architecture for sharing functionality and data between different applications. And the way I look at APIs is they're like windows to an application, right? A direct channel that leads straight into the core functionality and the data residing in your application, which can be a core application. And today we are seeing that APIs are becoming the mainstream to expose the key business services, and organizations today, they are really seeing the benefit of APIs coupled with the microservices architecture, right? Coupled with serverless code more than ever before. But why are these APIs important? The APIs are important because it helps exposing the data and it accelerates the mobile and the web application delivery. It helps in improving the overall customer engagement. And there are organizations who are using APIs to expose data and identify and create new revenue channels and opportunities for them. So far, you all will agree with me that APIs are really popular these days. The popularity of APIs and the varied ways in which organizations or enterprises leverages API, they are attracting hackers, they are attracting bad actors today. And as business opportunities increasingly rely on the digital connection, each point of the interaction becomes a potential source of a risk when it comes to API. These are some of the APIs attack or APIs vulnerabilities or threats that are the most common one over the last 2 or 3 years. And if I were to talk about a couple of them, I would love to talk about the API parameter tampering attack, which is one of the most common exploits used by the hackers to probe into your application security defenses by just tampering the input parameters, right? The fields that you use for input, right? With APIs, such tampering could be used to do reverse engineering to an API, causing DDoS, reflective DDoS kind of an attack, and thereby exposing a poorly written API to reveal more data. So that's API parameter tampering attack for you. Man in the middle attacks, which is where the unencrypted connection between your API client and API server leads to exposing the data of the sensitive data to the hackers. You have credential stuffing, you have brute force attacks, so on and so forth. I would like to talk about something that we are really proud of when it comes to Google security solution. So recently, we revealed some details around the size and the type of DDoS attack that we see here at Google. What you see on this particular graph is part of a blog post that shows the exponential growth we have seen in the attack sizes over the last 10 years or so. This is across 3 dimensions, as you can see out here: the bandwidth, the packet per second, and the HTTP or HTTPS request per second. And I would like to talk about 2 use cases very quickly out here. So the first big attack we disclosed was a new bandwidth peak, right? We actually saw in 2017, which peaked at 2.54 terabytes per second and is one amongst the largest disclosed DDoS attack. The peak of the attack used multiple networks and peaked at 167 million packets per second, which is humongous. And the attackers, they used a mix of connectionless LDAP, they used DNS, they used SMTP servers to amplify the attack, which made it even more bigger in the size. Other use case or other attack or the scenario that I wanted to talk about is the fully formed HTTPS request attack, wherein we saw 6 million requests per second, which was launched against one of our customers. These type of massive attacks are generally done using a mix of bots, legitimate end user browsers with man-in-the-middle JavaScript injection or cross-site scripting kind of attack. Only then these kind of attacks are made possible. But what we are really proud of is the depth of technology, the depth of experience, and the massive infrastructure that Google has, and it positions us in a very unique spot to provide best-in-class DDoS protection at a planetary scale. So now let's dig into how you as an organization can mitigate some of these threats using Google Cloud Platform. And for that, I would love to hand it over to Sai and understand how we can make use of the GCP services or the Google Cloud Platform services, and what are the various best practices that he has to share with us. Sai, over to you.
Thanks, Sachin. That was great context setting over there. So API and application security is extremely important for many organizations. Sachin just alluded to that. Let's talk about API security, as this is a huge topic. Now, as a solution architect, I work with a lot of customers to architect solutions around infrastructure, networking, and security. Now, in this use case, we have a fictitious financial customer who has services deployed in different ways and has different types of consumers, like their actual end users, partners, employees, and many more. They have microservices deployed in their data center and in the cloud. They also integrate with third-party systems to get more data externally. Now, in this current state, the architecture has a few constraints, right, that I'd like to highlight. No consistent security best practices across these services as they're built by different teams. They're all in siloed fashion, so they could be using different protocols. One service could be using OAuth with opaque tokens. The other system could be using JOT tokens, and you might still have legacy systems using basic auth and legacy authentication services. That's one. The other factor is logging and rate limiting. Now, these capabilities will need to be handled by individual services, and the teams need to put extra effort to do all that consistently. It's not easy to scale as you have one load balancer for everything. It becomes super complicated when the number of services increases as you expand your portfolio. Last but not the least, it becomes very important that you will not be able to actually use the system to support and protect from malicious attacks. So these are some things that I like to highlight. And for this is where Apigee, Cloud Armor, reCAPTCHA Enterprise, and Cloud CDN can add value. It makes it easy and seamless to expose these services. Next slide. Before we jump onto the best practice, I want to spend a few minutes on the different GCP products we will be using in our best practice architectures. Now let's start with Apigee. Apigee is an API management platform that provides a single point of management for APIs through the entire lifecycle from both a development and operations perspective. The platform inspects API requests to protect, scale, adapt, control, and even monitor API traffic. Now, Apigee's out-of-the-box policies enables developers to augment with features like to control traffic, it could enhance the performance, and more importantly, enforce security without requiring them to add any additional code or modify the backend services. Now, building security around an API can take time. We all know that, and it requires significant expertise. But Apigee can provide this to any API in minutes. Now, security policies let developers control access to APIs using different mechanisms that Apigee offers, which is OAuth, API key validation, or any other threat protection capabilities. Now, Apigee allows you to productize your APIs, which provides governance as to who can access them and provide analytics to understand your consumer base and also improve your APIs. Now, it is integrated with other GCP services, including IAM and cloud logging. Next slide, please. It is very important to apply security policies and governance throughout your digital interaction. Now, what you're seeing here is the digital value chain. This actually represents a digital interaction and the various personas participating in this interaction. As you can see, for each persona from left to right, there are different security aspects that can be applied. For example, on the extreme left, for the end user, you can apply protection against OWASP attacks like SQL injection or cross-site scripting. Similarly, to the end services to the extreme right, we could apply policies like allow, deny, access control, encryption, mutual TLS, so on and so forth. Now let's talk about Cloud Armor. Cloud Armor is a DDoS protection service and a web application firewall. It provides global scale defense against volumetric, protocol, and application attacks, offering the same protection for hybrid and multi-cloud workloads as it does for ones on GCP. And the important aspect is it's built using the same technology and infrastructure that we originally built to protect our own billion user properties such as search, Gmail, and Maps. So it can really scale. With Cloud Armor, customers can actually filter incoming requests by geography or layer 7 parameters like request headers, cookies, or query string. Moreover, as a WAF, Cloud Armor contains pre-configured rules to prevent against the most common attacks and vulnerability exploits. It also offers real-time telemetry containing Cloud Armor's decision on a per-request basis, as well as provides all the information on the monitoring dashboard that gives you details around allowed traffic, denied traffic, or previewed traffic. Now, going back to our digital value chain we saw a few slides ago, Cloud Armor contributes to the implementation of several of these key controls, as often described by compliance and best practice across security and governance. For example, the advanced global policies, behavior-based protection, spikes, and many more can be configured across the digital interaction very easily using Cloud Armor. Next is reCAPTCHA Enterprise. reCAPTCHA Enterprise is our fraud and bot protection product. It leverages our learnings with reCAPTCHA that already protects millions of sites on the web. Security teams often benefit from enhanced detection, such as extra granular scores, reason or error codes, and the ability to tune the risk analysis engine to their site's specific needs. And then the system provides a risk score allowing for progressive action. For example, depending on the risk score, an incoming request can trigger a requirement for a second factor. It could be outright blocked, redirect, or even allowed through. Like other GCP solutions, it provides rich telemetry around interactions, scores, and actions. Now, as you can see from this graphic, reCAPTCHA identifies and defines all the illegitimate traffic, like a fraudulent transaction, account takeovers, money laundering, so on and so forth. Last but not the least, let's talk about Cloud CDN, which is a fast, reliable web and video content delivery cloud product with global scale and reach. It helps with cutting down on all the number of backend hits, thus reducing bandwidth cost and protecting your backend from DOS attacks, especially during peak traffic. It enhances the user experience by bringing the content much faster to the end users. Like other GCP products, Cloud CDN also is tightly integrated with cloud logging and monitoring, providing detailed latency metrics.
Sai, can you now help us connect the dots and help us understand some of the best practices leveraging the services that you just talked about?
Awesome. You're just going to the right track. That's precisely what we'll be talking in the next few slides. Now that we've kind of understood what the different products are, let's see how we can use these products and create different best practice on the same earlier fictitious financial customer use case we saw a few slides ago. So let's keep going. So in our first best practice, we will be talking about using Apigee as a proxy layer. In this solution, Apigee is used as a reverse proxy, which includes security policies like token validation, API key validation, rate limiting, quota, message level threat protection, and many more without making any change to the backend. Apigee can be used for routing also. It can actually be used for routing the request to different backends. Now let's take a request flow and talk about how the client request and response flow works in this particular scenario. Now on the very far left, the client sends the request to an external HTTPS load balancer with the credentials for the application. Now this credential could be a key, token, or a certificate. Now the load balancer routes the request to Apigee. Apigee processes the request, executes the security policies, and allows or denies the request. Then Apigee can be used to route the request to different backends based on the client, the request, or both the client and the request. Now in this architecture, Apigee forwards the request to the GKE backends directly through internal IPs. The communication between Apigee and the money transfer service you see on the diagram can happen over RFC 1918 ultraspace because they are within the same GCP peer network. Apigee can also send the request to the private data center through Cloud Interconnect. Lastly, Apigee can also send the request to a third-party system over internet or mutual TLS via the Apigee NAT IPs. Now let's talk about the value prop here. The value prop is that Apigee as a proxy will provide a consistent security layer across all your APIs. With concepts like flow hooks and shared flows that are available in Apigee, you can enforce policies for access, rate limiting, logging, and many more across all your APIs within minutes.
Wonderful. I think the key word out here is the consistent security layer. So that's a good value proposition sign. Thank you.
Absolutely. Absolutely. Now let's take it to the next level, right? Now in the second best practice, what we're going to be doing is we're going to be adding Cloud Armor as a WAF along with Apigee. Now you can configure rules and policies in Cloud Armor to evaluate every call made by the client that hits the HTTP load balancer. The flow of event in this architecture is very similar to the previous one that we just saw. Let's talk about the request flow. Now to the very left, the client sends the request to the same external HTTP load balancer with the credentials for the application. Now Google Cloud Armor filters the request as the load balancer is now configured with Cloud Armor. It enforces and evaluates all the configured rules and policies basically to protect your application from DDoS, geofencing, and OWASP attacks. If any rule is violated, it rejects the request and sends out an error message and a status code. But if there are no violations, the load balancer routes the request to Apigee. Apigee then processes the request, executes further security policies, and allows or denies the request. Similar to the previous pattern, Apigee can be used to route to different backends using internal IPs, cloud interconnect, and NAT IPs. Now, the value prop. The value prop is that you are very easily able to plug in a WAF to this overall architecture and get all its features. This requires no downtime and it increases the overall security footprint within minutes.
Wonderful. Moving on to the next one, Sai. Thank you. That was a good one.
Yeah, thanks. Now moving on to the third best practice. In here, we're going to be adding Cloud CDN. So as you can see, we're progressively adding new products to it to enhance your overall security footprint. Now in this third best practice, we will be adding Cloud CDN, which is meant for caching. Now, as discussed earlier, Cloud CDN offers caching capabilities that help you to secure the backend by returning the response from the cache. And now by caching frequently accessed data at the edge of the Google network, it keeps the data as close as possible to the users and allows for fastest access. Now let's talk about the request flow again. On the left, the client sends the request to an external HTTP load balancer. Cloud CDN is enabled on the load balancer, which checks for the cache with the cache key and returns the response if the cache hit was true. Now, if the cache hit was false, what happens? Cloud Armor is enabled and it goes through all the enforcement policies that is configured within the Cloud Armor. Now, if Cloud Armor rule is violated, it rejects the request and sends out the error message. But if there are no violations, the load balancer routes the request to Apigee. Apigee then again executes further security policies if configured and allows or denies the request. And similar to the previous patterns, it will also forward the request to the appropriate backends. Now, the important aspect here is the response flow back. Now, on the response flow back, Cloud CDN caches the response so that it can return the response from the cache for any future subsequent calls that matches the same cache key. Now, what's the value prop here? The value prop here is better response time, reduced network and bandwidth cost, which is important, and most importantly, from a security perspective, it is reducing the number of hits to the backend applications, thus increasing the overall availability of your backend services, which is a key metric for any organization out there. Exactly. Now with that, let me hand it over to Sachin to talk about the fourth best practice, which is more of a solution called WAAP. Over to you, Sachin.
Thank you, Sai. That was a good demonstration of the best practices. As I mentioned, so the fourth best practice that I want to talk about is what we call it as a WAAP, which stands for Web Application and API Protection. Today, most of the organizations, they are challenged with trying to protect their web applications and APIs against many different type of attacks, which we talked about in the beginning of the conversation. What we are seeing is customers, they purchase different pointed solution for each of these type of threats, which leads to a gap in the overall security posture, number one, and it also increases the overall acquisition cost and the operation cost for our customers. So the answer to such situations or such scenarios is WAAP. So Google's WAAP as a solution addresses four key security aspects. Number one, it addresses the web application firewall requirements for our customers. It acts as a distributed denial of services protection solution. It helps mitigate bot management and it helps address bot scenarios. And lastly, it provides a very comprehensive API protection capabilities that Sai talked about in the first three use cases. Let's go deep in what the WAAP solution is all about. So the high-level architecture is what you see on this particular slide, and it is a solution which is based on the same technology that we use internally within Google to protect the public-facing services like Google Search, Google Workspace, YouTube, etc. And it provides the same protection against all the existing and the new emerging threats that I just talked about. The solution comprises of three key Google Cloud Platform services, namely Cloud Armor, Apigee for API management, and reCAPTCHA for advanced bot and fraud detection kind of capabilities. You would be interested in knowing that since this is a solution-based approach, what is the value proposition of such solution? And I will be more than happy to talk about it very briefly. The, the very first benefit that we often hear from our customers is that WAAP solution provides a very comprehensive threat protection solution, meaning by if you want to ensure that your applications and APIs are continuously available, they are continuously protected and are in compliance. At the same time, they are being protected against the threats. That's what WAAP solution brings onto the table for you, because using a solution approach, you can address DDoS, you can address web attack, you can address advanced bot and API protection all as part of one single solution. The second value proposition is around WAAP Anywhere from a deployment perspective. So the WAAP solution protects your applications in Google Cloud. It can also protect your applications if they are on-premise or if they are deployed in any other cloud, right? So we know that most of our customers are multi-cloud or they have a hybrid deployment, and that is where Google WAAP solution can be used to protect all the applications no matter where they are deployed. So that's WAAP Anywhere for you. Third is the simplification of the operation. So customers often want to reduce the number of vendors they need to work with in order to protect the app. And that's where WAAP as a single solution can address and mitigate most of those concerns around how you can simplify your operations. Lastly, it will help you to reduce your overall spend on the security solution. So by using WAAP solution, you can potentially save maybe 50 or 60% of the cost when compared to similar solutions that are available out there. I want to continue with the same pattern which Sai talked about, because that's a wonderful pattern to understand how the flow works and what kind of solutions can be placed and where they can be placed to address various security needs. So we often recommend WAAP for enterprise use cases where API calls are made from a website or from a mobile device or from applications. You can set applications to load the reCAPTCHA enterprise libraries to generate a reCAPTCHA enterprise token and send it along when they make a request, right? And that's what reCAPTCHA enterprise is really good at. Let's quickly look at the flow out here, right? So in this particular scenario, so the client sends the request to an HTTP load balancer with the credential for the applications. As I mentioned, it can be a key, it can be a token, or it can be a certificate. Now, because HTTPS load balancing has Google Cloud Armor enabled, the Cloud Armor selects the request. It enforces and evaluates all the rules that are configured as a part of the policy. And if any rules are violated, the Cloud Armor reject the request with an error message and a status code, sending it back to the consumer or the user. For the website calls, such as a form submission for a login page, Cloud Armor is integrated out of the box with the reCAPTCHA Enterprise, as you can see on this particular image. reCAPTCHA Enterprise evaluates the incoming traffic and adds a risk score, which is really good capability of the reCAPTCHA Enterprise solution. It adds a risk score to a legitimate traffic, and for the traffic that is not legitimate, Google Cloud Armor can deny the request. So basically, you are handling those good or bad scenarios at the perimeter itself. If there are no Cloud Armor rules that are violated, the HTTPS load balancer routes the API request to the Apigee, something similar to what Sai talked about. Apigee can forward the request to the GKE backends, whether they are hosted internally or they are hosted externally, or the request can be routed to your data center as well through Apigee NAT IP addressing, right? So that part of the flow remains pretty much similar as I talked about in the previous best practices. We did touch upon the fact, but I just want to reiterate the fact that why Google WAAP solution is important. Just to reiterate, it provides a very comprehensive threat protection solution. It can be deployed anywhere. It helps organization to simplify the operation using one single security solution, which eventually help you to reduce the overall spend on the security solutions. With that said and done, I know we had been talking about the security, the use cases, and the best practices. I would now take the opportunity to give you all a quick walkthrough of one of the solutions that we had been talking as a part of the best practices. So allow me a minute. I will switch screens and we'll go from there. So if you can see here, I am currently logged into my Google Cloud Platform console, and I'm on the home page of it. So I want to quickly navigate to the network security and into the Cloud Armor section. And this is where we have created the policy, what we are calling it as a WAAP demo policy. Let me increase the font size just to make sure that you all have a good reading experience. So this is where I have created a policy within the Cloud Armor. And if you see out here, I am under the rules section. So this is where we have created 4 rules. The first and the second row is more about the custom rules, wherein I am looking for a user agent if it contains the word hacker, and if the traffic is coming from US or if it is coming from Canada. I want the traffic to be blocked at the perimeter itself. And I want to generate a 403 error code out here. So that's the rule number 1 and 2 that you see on this particular policy. Rule number 3 is more of an OWASP rule. So the beauty of the Cloud Armor solution is that it comes pre-configured with certain rules to address and mitigate OWASP top 10 vulnerability. In this particular scenario, we are leveraging the OWASP rule to address SQL injection kind of an attack. And that's what I will be demonstrating. The 4th rule is around allowing the traffic for all these IP addresses. I want to grab your attention to the priority section. So you see I have assigned different priorities to different rule sets, namely 6,000, 7,000, 9,000. So as the traffic comes into the Cloud Armor, the rules are executed based upon the priorities that are being assigned. So the first rule that will be executed out here will be the first rule, wherein the user agent is hacker, traffic coming from Cloud Armor because it has a 6,000 priority, and then 7,000 and then 9,000. I will navigate into the target section. So this is where you can create the target applications or the APIs that you want to protect using Cloud Armor. So in this particular demo scenario, we have 2 target backends that we are protecting. One is the Apigee proxy backend, and that's where we wanted to showcase the integration between Cloud Armor and Apigee hosted APIs. And we are also protecting a Juice Shop app, which is an open source application which is hosted on Google Cloud Platform. So we want to make sure that we are protecting this particular application here. Navigating on to the 3rd section, which is the logs. So if you go out here, you can see the logs for all the action that you will be happening at the Cloud Armor layer. So what I'm going to do for demo purposes today, I will bring in my Postman client, and I would like to showcase how we can mitigate some of the attacks using the custom headers out here. So allow me a quick minute. I will bring in my Postman client out here, and I hope you all can see the screen. So give me a thumbs up if you can see.
I mean, can you zoom in a little bit?
All right. Is this better?
Not really. Can you zoom in to see the font or the text?
Zoom in. Alrighty. Is this any better now?
Yeah, this is much better. Thanks.
Wonderful. Thank you, Sai. So as you can see out here, I am making a call to this particular endpoint, and I will first make a call wherein I'm using a default user agent. And if I make a call, you will see that I'm getting a traffic back from the particular backend system. However, when I select the user agent as a hacker, so wherein I'm looking for the keyword hacker for my incoming traffic, Cloud Armor should block this traffic, and it will give me a 403 error out here, as you can see out here. How can you double check this particular error? So I will go back to my log screen, and this is where we will go into the logs, and we will look for a particular traffic and the logs that are being captured at the Cloud Armor level. So if you see out here, the very first log, if I expand it further, you will see that has been blocked by Cloud Armor, wherein the custom header was looking for the keyword hacker. If I scroll down further, how will you see that which rule was enforced? So you will see that We were looking at the WAAP demo policies. The outcome was denied because we had a force active deny rule there at the Cloud Armor level. And the rule with a priority of 6,000 was activated, which blocked this particular request at the Cloud Armor level. So that's the demonstration of the use case wherein you have a custom header. I will now go on to demonstrate the use case wherein we have a SQL injection kind of a use case. In order to do that, what I want to do is I want to do a contrast and compare kind of a scenario. So this is the OWASP juice shop that I was referring to. So think of it as any e-commerce app wherein you can go and you can select the product, you can see the reviews, so on and so forth. I have two instances of this app hosted. So one is hosted without any SQL protection, and the one I have hosted on the GCP, we have enabled it to be protected by GCP, as I showed you in the targets. So if I log in into this particular app, I will log out first, and then I will go back to login. I will use the same parameters for both the applications. And when I give my email ID and a password using a certain parameters, you will see that I am able to log in and I can navigate into different products. I can see the reviews, so on and so forth. However, when I navigate to the second application, which is being protected by Cloud Armor as one of the app targets, and if I use the same credentials here, I will be blocked. You will see that we got an error out here. Why was this application blocked? Because we have protected this particular application using the Cloud Armor. And if I go back to my logs and run the logs again, you will see that we got an error out here. If I expand this further, this time the rule with the priority of 9,000 was activated and it denied the incoming request, meaning by the SQL injection attack was in play. And the application which was protected by Cloud Armor blocked the incoming traffic because it was a wrong parameter that we provided from a login perspective into this particular application.
So Sachin, this is super cool. So the login credentials that you used to log in to both the apps, one with WAP enabled and the other one without the WAP enabled, you were trying to infiltrate an issue of injecting a SQL injection attack. Is that accurate?
That is 100% accurate.
Okay, cool.
I wanted to demonstrate how easy it is to protect any web application just by doing 2 or 3 clicks from a configuration perspective and have it protected by Cloud Armor. And these kind of rules can very easily be used to mitigate SQL injections or regular expression kind of an attack, which can be done at the perimeter or edge layer itself.
Super cool.
Wonderful. Moving on to the next one. From here, I want to give you a quick walkthrough of the Apigee platform as well. So if I go out here, I'll go to the Apigee X platform. And from here, you will see that I am on my Apigee homepage. What you will see out here is, as Apigee is an API management platform, the storyline of the API lifecycle resonates really well, wherein as an API developer, you will go out here, you will create your API proxies, then you will create API products, which is nothing but the concept of the digital product by combining multiple API proxies and exposing them as a digital product. Once you have created your API products or the digital product, you can go and create your own portal platform. This is where you can catalog your APIs, you can document your APIs, you can enable the self-service developer onboarding experience, so on and so forth, using the Apigee platform as well. Very quickly, going into the API proxies, the proxy that we have created for demo purposes today is, I'm calling it as OWASP Juice Shop. And if you recall, this is the same endpoint that we protected using Cloud Armor as my second target. On
So
this
this is the API endpoint. Sorry, this is the API endpoint that the application, as in the Juice Shop application, is making when you interact with it. Is that correct?
That is correct, yes. Over here on the home page, you will see a quick snapshot of the health of this particular API proxy. So you will see that we are using revision 7, which is deployed on the demo environment. My proxy endpoint base path is /OWAPs, and my target endpoint is the WAP demo GCP security solutions. Moving on to the navigate section, I'll increase the font size here as well for a better readability. Moving on to the develop section. So this is where all the magic happens in terms of the ability to allow developers to add policies in a very configurable manner, or more of a drag and drop kind of an experience that Sai talked about when introducing the Apigee platform. Just to give you an idea how you can add those policies, if you click on this plus step icon on the pre-flow, Apigee will give you the out-of-the-box policies that we have available under different heads, namely traffic management, security. You have XML protection, JSON, OAuth, API key validation, SAMLs, JOT, so on and so forth. And then there are many out-of-the-box policies under mediations, which deals with open spec validations. You have SOAP message validations, key value map operations, so on and so forth. Last set of policies, they fall under the extension head. This is where the concept of heterogeneity comes into the play, wherein Apigee can leverage these extension policies to make connections or make interfacing with the systems which are outside the scope of the Apigee using these standard policies. For demo purposes today, what we are doing is we have added two policies under the search call for this particular endpoint. We have a spike arrest policy, and this is where we are limiting the incoming request. If you pay attention to row number 7, we are only allowing 6 requests per minute for this particular search call. And we are also doing an API key validation out here. So we want to make sure that only the applications or the users which have a valid API key can make a call out here. I will navigate onto the debug section. I will select this particular API proxy, and I will enable the debugging session so that you can see the traffic. Now, if I go to the Juice Shop Factory app, which is this app, and let's say if I search for apple juice, and while I'm doing that, you will notice that you will start to see traffic going through the API endpoint that I just turned on the debug. So if I go out here, you will see that you have some traffic flowing into your Apigee debugging session. And over here, you will see that we looked for reviews, we looked for search product, search call was made, so on and so forth. Now, you want to see the rate limiting in effect. So for that, again, I will bring in my Postman client out here, and I will make a few calls to this particular endpoint, which was the OWAPs base path, which I showed you. I'll make few calls, call number 1, 2, 3, and you will see out here that we got few calls, and the last call returned me a 429, meaning by the spike arrest or the traffic management came into the play, because we configured it to allow only 5 or 6 requests per minute. So that's this rate limiting that can be done at an API layer using Apigee as an API management platform. Now, another use case that I want to talk about is, what if a man-in-the-middle attack can happen from an API perspective? So let's say there is a notorious user who wants to make a call to this particular endpoint without providing a valid API key. So this, which is this particular case. So I'm making a call to this particular endpoint. I'm searching for food, and I'm making a call. So you will see that Apigee will throw an error. And if I go back out here on the trace or the debug, you will see that this time, even though the spike arrest was good, but it failed at an API key validation because the notorious user was able to get hold of the endpoint, but he or she did not have a valid API key. So Apigee was very smart at that particular aspect of making sure that a valid API key is provided in order to extend the backend system. So that's the art of possible that we can do with Apigee as an API management platform, leveraging out-of-the-box policies. In the interest of the time, I'll just quickly showcase you the placeholders for analytics. We focus a lot on the monitoring aspect of it because we want to give you different views of how you can analyze and how you can use the reporting for your API ecosystem. So you have API monitoring, which gives you a near real reporting of your APIs. This is where you can see the total traffic, you can see the error rate, you can see the latency, and how your overall API ecosystem is behaving in a near real-time kind of an environment. You have another view, which is of an API metric view, and this is more of a historic view. This will give you the total traffic, the response time, the developer experience, how many developers are using your digital products or your portal platform, the traffic composition, so on and so forth. So that's the Apigee platform on a very high level. I will now navigate back to my slide deck and we will do a quick recap out here in terms of what we discussed. So we talked about 4 best practices to secure the APIs and the web applications. So the first one is using Apigee as a proxy layer. The second use case which Sai talked about was using Cloud Armor as a web application firewall along with Apigee and front-ending the Apigee workload. So this is what we demonstrated as a part of the demo, wherein we were protecting the Apigee backend using web application firewall, which is Cloud Armor. Third use case focused on using Cloud CDN for caching. So this is where if you want to improve the performance and you want to reduce the latency, we can leverage Cloud CDN in addition with Cloud Armor, reCAPTCHA, and Apigee. And the fourth use case was around web application and API protection, wherein we can leverage Cloud Armor, reCAPTCHA, and Apigee to provide a comprehensive security solution. With that said and done, I would like to share some of the collaterals that we have published around application security and web application security. We have blogs wherein Sai has shared his perspective in terms of how you can leverage other security solutions as well. So to learn more, please check out the blog and the best practices guide. You can learn more about the WAAP solution on our website, which is Google WAAP Solution. We have a very active Google community for Apigee, for Cloud Armor, and the other GCP services that we talked about today. Please do not hesitate to participate and post your questions that you may have. We will be more than happy to answer those questions for you. With that said and done, we would like to thank you for your time and your participation. Hope you find this helpful, and thank you again for your time.
Thanks a lot.